Hi everyone, welcome to this video recording. We are going to be looking at an exam question, CT5. Oh, it's written here, sorry, April 2014, and it's a question that you can find on the IFOA website for past year papers. So you can also find the examiner's solution there. Let's talk about this. You'll find this quite helpful for those of you who are taking the CM1 exam in September. Yeah. So let's try and look at this. Calculate the expected present value. So we have to find the expected present value and the variance. So there are two things to do of this term here. Now this is what's wrong with this problem. Yeah. That's why I wrote in my handwriting here, where's the random variable? So this question is kind of defective. Yeah. So they should have mentioned something like, they should have talked about the product. Yeah. Because when we talk about the present value, okay, when we talk about the expected present value rather, and the variance. So when we talk about expected values and variances, we are looking for random variables. So they should have mentioned something about the present value random variable representing a certain product. Okay, in this case, it will be a term assurance product. Yeah, it will be a term assurance product, term of 20 years. Okay, the present value random variable representing this product, a term assurance product, term of 20 years, and the benefit of one. Yeah, a benefit of one, which is payable. There's a bar here, so immediately on death. Yeah, immediately on death. So they could have said this, but they left it at this and expected the students to, or those taking the exam at that time, to catch on. So, okay, enough about that. We have to appreciate the work done by the examiners. Yeah. Okay. So let's see what is the information given. Mortality is good. Constant force, mu x is 0.03 for all x. And you're given the force of interest, delta is 5% per annum throughout. Great. These are the answers from the um, examiner's report for this exam. So you can actually Google it and look up the solution that is presented. Now I have done the solution here myself. So we're trying to find this quantity here, the expected value, okay, the expected present value. So let's move that up. We are dealing with constant force. So what's the big idea? Okay, so the big idea is, since we are trying to find expectation, okay, since we are trying to find expectation, the fundamental idea will be what? X fx. Yeah, that's it. Yeah. Now we are dealing with something which is continuous, so we'll have an integral. Yeah, that's it. So in this case, your present value random variable will be vtx, and what else? The density function. Yeah, the PDF of tx, which is tpx mu x plus t. That's it. Yeah, and because we are given the force of interest, we will write v as equals to, remember we have got, let me write that again, 1 plus I is e to the power of delta. So 1 plus I raised to the power of minus 1 will be v, which is e to the power of minus delta. That's it. So to find this expected present value, all you have to do is include your v to the power of t, which is e to the power of minus delta, and a t here. There you go. And your density function, which is tpx mu x plus t. Again, this is your discount function, and this is your density function. Yeah, density function of tx. Great. So now you can plug these in because you know that we are dealing with constant force. So tpx is what? E to the power of minus mu t. So I've done that here for you. Okay, I've done that here for you. And we know the force of interest, so we can plug that in as well. So we have e to the power of minus 0.05 t. The term of 20 years, so your integral, the limit is going from 0 to 20. And of course, we have this mu here, which is constant. So you clean this up, you'll get a simple integral, which you can do yourself. Cleaning it up, plugging in the values of 0 and 20 and stuff like that, you'll get an answer of 0.29929. I'm not talking about the integration because that's easy for us to do. Okay, so a quick word about the variance. The only idea for variance is your second moments. Okay, second moments minus your first moment squared. Yeah, first moment squared. That's all we're doing. So let's move the screen up. And the only thing now, because you already have your first moments, okay, you already have your first moments, 0.29929. All you need to work out is your second moments. So I've done that here for you. Okay, I've done that here for you. Um, your second moments, remember what happens? Your delta becomes 2 delta. Yeah, the force of interest becomes twice the force of interest. So that's what you see here. Nothing else changes. Yeah, e to the power minus mu t. We have mu is 0.03. This thing here, earlier it was just delta. Now it's 2 delta. Plug that in, set up your integral, and you will get your second moments when you evaluate your integral. Okay, going from 0 to 20, you will get 0.21362,917. Okay, so all you have to do is now find the variance, plug these numbers into the formula. Okay, your second moments minus your first moment squared, and that's what I've done here for you. Okay, I've done that here for you. Your second moments minus your first moment squared, and you'll get your final answer 0.12406, and we are done. Okay, thank you very much for watching, and if you have any doubts about this question, please do reach out to me. I'll be able to help you out with these things. Yeah, okay, good luck in your studying as you approach your exams. Thank you for watching.